everyone, my name is Vijitra anak perempuan Segaran and my metric number is 198839. In this video, I will revise on one of the method from chapter 6 where we are solving linear system with Laplace transform. So let's take a look at one example. So the question is solve 2x prime plus y prime minus y equal to t, and the other equation is x prime plus y prime equal to t square, where the initial value given is x0 equal to 1 and y0 equal to 0. So in this method, the first step we need to do is we lack the Laplace transform of function x equal to us and the Laplace transform of function y equal to vs. And then next step is we take the Laplace transform to both sides of the equation given. So here got two equations, so we proceed one by one. So for the first equation, we take the Laplace transform for the both sides. So we have Laplace transform, the left side is 2x prime plus y prime minus y, and then the right side is the right side is the Laplace transform of t. Here is the right side. Okay, so this part we can separate the Laplace transform. So we get 2 Laplace transform of, here is the Laplace transform of x prime plus Laplace transform of y prime. Here is minus the Laplace transform of y equal to Laplace transform of t. So to solve this, we just look through the table of Laplace transform. So here is the one of the example of table of Laplace transform that we can find from the internet. So here I already looked through the Laplace transform table, and then we get the property from the number 36, the Laplace transform of f prime equal to s, Laplace transform of f minus f0, and then for the right part, the Laplace transform of t power of n equal to n factorial over by s power of n plus 1. So here the Laplace transform of x prime is equal to 2 times with s, and then here Laplace transform of x minus by x0, and then here plus the Laplace transform of y prime is equal to s Laplace transform of y minus y0, and then minus Laplace transform of y. Laplace transform of y is vs equal to Laplace transform of t power of 1, so we get 1 factorial over s, n plus 1 is 1 plus 1, and we solve this. The Laplace transform of x is us, so we substitute, we get 2s us minus 2. Our initial value is x0 equal to 1, so we times 1 plus s, Laplace transform of y is vs minus the initial value for y0 is 0 minus vs equal to, here we got 1 over s square, and then we just simplify it. So we get 2s us plus okay, here we get 2, here we can move to the right side, so we get plus s vs minus vs equal to 2 plus 1 over s square, and then this one we can factor out the vs, so we get 2sus plus s minus 1 vs equal to 2 plus 1 over s square. So here we can note as the first equation. So next, so move to the next part when we have to take the Laplace transform for the second equation. So we take Laplace transform to both sides of the second equation. So we get Laplace transform of the left side is x prime plus y prime. Then the right side is Laplace transform of t square. So also we can separate this part. So Laplace transform of x prime plus Laplace transform of y prime equal to Laplace transform of t square. Then we just take a look from the table of Laplace transform and then we solve this. So we get here is become x Laplace transform of x minus x0 plus s Laplace transform of y minus y0 equal to, here we got 2 factorial over f power of 2 plus f power of, we get 2 factorial over s power of 2 plus 1. Then we solve this s and then us minus here x0 equal to 1 plus s vs and then y0 equal to 0 equal to, we get 2 over s cubed, and then we can factor out, okay, so we can move the 1 to the right side, so we get sus plus s vs equal to 1 plus 2 over by s cubed. So we know this thing is second equation. So now we finish with step 1. So we move to the step 2. The step 2 is we need to solve for the first and second equation just now simultaneously to find the function of u, to find the us and vs. So here the first and second equation just now, so we solve it simultaneously. So let's do this. So here we can eliminate the us by we time the second equation with 2. We time the second equation with 2, so we get 2su us plus 2svs equal to 2 plus 4 over s cubed. So here we know as equation 3. And then the next step we can minus the first equation with the third equation. First equation minus the third equation, and then so we will get the 2sus minus 2sus, so we get 0, and then this minus this, so s minus 1 minus 2s vs equal to this 2 minus 2 becomes 0, and then we have 1 over s square minus 4 over s cubed. So here, so we try to simplify this, so we get minus s minus 1 vs equal to 1 over s square minus 4 over s cubed. And then here we can bring out the minus, so we get minus s plus 1 vs equal to 1 over s square minus 4 over s cube. The next step is we can these two fractions we can simplify it to become one fraction. So we get s, we time this the upper and lower with s, so we get s minus 4 over by s cube, and here minus s plus 1 vs. Then we can find the vs. We move this side to this side, so we get equal to s minus 4 over by minus s cube s plus 1. So the minus here we can move to the upper side, so we get vs is equal to minus s minus 4 here, and then s cube s plus 1 actually equal to 4 minus s over s cube s plus 1. So here we get our vs. So next step is we need to find our us. So to find the us, we can use the second equation. So here from 2 we can factor out the s, so we get s equal to us plus vs equal to 1 plus 2 over s cube, and then we can move the s into the right side, so we get us plus vs equal to 1 over s plus 2 over s power of 4, and then we move the to find we find us, so we move the v into the right side, become minus vs equal to 1 over s plus 2, here is minus the s plus 1 over s plus 2 over s power of 4. So here is our us and here is our vs. We no need to you can decide when you want to substitute the vs first before doing the inverse Laplace transform, or you can substitute the vs later after you done with the Laplace transform. So here I decide to do the Laplace transform, the inverse Laplace transform first, and then substitute the vs, so it will become easier for us. So we solve for y and x, where y equal to the inverse of Laplace transform of vs, and our x is equal to the inverse Laplace transform of us. So we solve one by one. So we proceed with to find the yt first. So we have to take the inverse of Laplace transform of vs. So here our vs just now is 4 minus s over by s cube times by s plus 1. So here we need to proceed with partial fraction to solve this fraction. So here we take the partial fraction, so we get a over s plus b over s square, because it the repeated one, so c by s cube, and then here we got d over by s plus 1. So we solve this, so we get as square plus s plus 1 plus bs s plus 1 plus c s plus 1 plus ds cube. Then here is over by s cubed s plus 1, and the right side 4 minus s over s cubed s plus 1. And then we try to solve this. 4 minus s equal to, we get as cubed plus as squared plus bs squared plus bs plus cs plus c plus ds cubed. So we try to factor out the s squared, s cubed, and s here. 4 minus s equal to, and then the s cubed is a plus d, factor out the s cubed. For the s squared, we got a plus b s squared, and then for s we got b plus cs, and then plus c. So we get the equation here. So where a plus d is equal to 0, and then a plus b equal to 0, b plus c equal to minus 1, and c equal to 4. And then we solve this simultaneously. Solve it simultaneously, and then we will get the answer for A, B, C, and D. So we have, after we solve these 4 equations simultaneously, so we will get A equal to 5, and then B equal to minus 5. Our C, we get our C equal to 4, and then our D equal to minus 5. So after we get the value of A, B, C, and D, so we just substitute into here. So we will get our Vs is actually equal to, our A is 5, so 5 our S plus our so our B is minus, so minus 5 our S square, and then our C is 4 plus 4 our S cubed, and then our D is minus 5 our S plus 1. So after we perform the partial fraction, so we get our Vs is actually equal to 5 our S minus 5 our S square plus 4 our S cubed minus 5 our S plus 1. So the next step is we need to, after we find our Vs, simplify our Vs using partial fraction. So we just take the inverse of Laplace transform to find our Vt. So here we take the inverse of Laplace transform of our Vs, and then this part we can separate it. So we have 5 over the inverse Laplace transform of 1 over s, minus 5 the inverse Laplace transform of 1 over s squared, then plus 4. Here we can, so we have to take a look at the Laplace transform table to find the inverse, and then we try to modify our Vs to get the inverse of Laplace transform. So here the inverse of n prime over by s power of n plus 1 is equal to Tn. So this we try to make this in this form. So we only so the above this, the lower part is 3, so the above is should be 2. So we just factor out the value of 2 here, so we get inverse of 2 over s3, and then plus 5 minus 5, and then the inverse of 1 over s. Here also we had to modify to become this form. So s minus 1. Yeah, so we just substitute the inverse of Laplace transform that we get from the table. So here inverse of 1 over s will be get 1. So equal to 5 times with 1 minus 5. Here we get 1 over s square is become t, and plus 2, and then here we get t square minus 5. Here we get exponent power of at, where our a is minus 1. So we get minus 5 exponent of minus t. So here we get the answer for the first solution. So we get yt equal to 5 minus 5t plus 2t square minus 5 exponent of minus t. Here we only get the first solution. So we need to perform the next step to find the second solution, where we have to find the solution of x. So for x, we take the inverse Laplace transform of us. Our us just now is so we get our us just now is minus vs plus 1 over s plus 2 over s power of 4. So we just take the inverse Laplace transform of our us, and then this part we can separate. So minus inverse of minus 1 of vs plus inverse minus 1 of 1 over s plus 2. Note here we have to modify this part to get the inverse of Laplace transform. So here we use the properties number 3. So we try to make it in this form. So here we got s power of 4. So the above part should be 3 factorial. So here the inverse Laplace transform of s power of 4, the above part should be 3 factorial. So to make this equal to this, we have to take 2 over by 3 factorial. 2 over 3 factorial. Okay, so this part. So we just substitute this. So we get, here we get the inverse Laplace of minus vs is actually equal to minus yt. And then the inverse of 1 over s, we will get 1 plus here is 2 over 3 factorial, so we get 1 over 3, and then here the inverse of 3 factorial, inverse Laplace transform of 3 factorial over s power of 4, we get t power of 3. And then, so noted here is minus yt, so we just substitute the answer just now into this. Minus 5 minus 5t plus 2t square minus 5 exponent of minus t plus 1 over 3 t cubed. So we just simplified this, so we get minus 5 plus 5t minus 2t square plus 5e minus t plus 1 over 3 t cubed. So we try to simplify this. So I take here minus 5 and then plus 1, so we get minus 4. Get minus 4 plus 5t minus 2t square plus 5 exponent of minus t plus 1 over 3 t cubed. So here we get our final solution for xt. So our xt is minus 4 plus 5t minus 2t square plus 5 exponent of minus t plus 1 over 3 t cubed. So here we get our final solution, where our yt is equal to 5 minus 5t plus 2t squared minus 5 exponent of minus t, and our xt is equal to minus 4 plus 5t minus 2t squared plus 5 exponent of minus t plus 1 over 3 t power of 3. And then here we get the final solution. So that's all from me. Thank you.